Number 3 on the 2025 AP Precalculus exam, the free response question part of the exam. This is the sinusoidal modeling problem, sinusoidal curve modeling problem. This appeared last year. This appeared in the sample question, so this looks like a common thing. Okay? And it looks like they're getting better at writing the question, so that it's not a grading nightmare for them. If I remember correctly, unless I read it wrong, in the sample questions, there was a incorrect concavity problem, actually, because that point where they were asking about the concavity was actually no concavity. It was a point of inflection. And in other ones, you can have an infinite amount of answers for these points over here and this model over here. So it's a grading nightmare. So it seems like this year they wrote it a bit better to limit the number of possibilities. Okay? Let's begin now. If that did not make any sense to you, if you're not interested in if you're not an instructor or something like that, and interested in the progression of this AP Precalculus course or whatever by the College Board, then ignore that. All right, here's how we solve this problem, how I would approach it. This is saying for a guitar to make a sound, strings need to vibrate, move up and down, okay? And it can be modeled by a periodic function. Time t equals 0, point x on one vibrating guitar string starts at its highest position, 2 millimeters above its resting position. Then it passes through its resting position and moves to its lowest position, 2 millimeters below the resting. Point x then passes through its resting position and returns 2 millimeters above. The motion occurs 200 times in 1 second, okay? So that's what's happening here. Start at 2, decrease, go to -2, and I'm giving parts of the answer already, right there, okay? The sinusoidal function h models how far point x is from its resting position in millimeters as a function of time t in seconds. A positive value of h indicates the point is above resting position, negative value below, okay? Graph of h and its dashed midline for 2 full cycles is shown. 5 points f, g, j, k, p are labeled. No scale indicated, no axes are represented. Draw possible coordinates t, h of t for the 5 points, okay? So it helps this time that they told us that t is in seconds and h is in millimeters. Okay, so this helps us to model it how they want us to, okay? So let's do the verticals first, okay? So the y value of f is at its highest position. So it told us it's at 2. So the y value is 2. Decreases to resting, which is at 0, okay? And then decreases to 2 millimeters below the resting, so we say that's -2, because negative is below, wherever it's at that, okay? And then it's back at resting at 0, and then back at the highest of 2, okay? So those are the y values. 2, 0, -2, 0, 2, that's the easy part. And then we can get the easy x value, a t value, sorry, for the first point f, t equals 0. Start, okay? Now how do we get the other ones? Well, we have to use this information here. This motion occurs 200 times in 1 second. What is that? That is the frequency of this sinusoidal function. What is frequency? It's like cycles per second. 200 times per second, same thing. Okay? So frequency is 200, and therefore frequency is related to period. How? They're inverses. Period is 1 over the frequency. Okay? So the period is 1 over 200. What is period? Period is how long it takes for the function to repeat itself. So it repeats itself, f repeats itself at p, right? So p is 1 period later. So 1 over 200. Okay? That's that one. Now how do we get the ones in between? Well, you can just imagine this is halfway between 0 and 1 over 200. So that's 1 over 400. This is halfway in between 1 over 400 and 0, so that's 1 over 800 over there, okay? And to get k, well, since we know the step is 1 over 800, pretty much for every quarter cycle, so this is 1 over 800, this is 2 over 800, which simplifies to that, right? This is 3 over 800, and this is 4 over 800, which is same thing as 1 over 200. Math works out. That's how we do this one. Oh, let me show the answers again. The important part was period and frequency. Knowing that the frequency is 200 and period is just 1 over frequency, okay? Now part B, now we have to model it and find A, B, C, and D, okay? So A is the amplitude. What is amplitude? Is how much it goes up or down from the midline or the average value. So if this is 0, we said this was 2, right? And it goes down to minus 2, so the amplitude is 2, A is 2. B is the angular frequency. Okay, if that doesn't make any sense to you, remember this B is just, period is 2 pi over B. Okay? And since we have the period equals, this guy equals 2 pi over B, so we can find what B is, or if you know what angular frequency is, B is just 2 pi f, where f is the frequency. So B is 2 pi f, as it says, so B is 400 pi. This is the easier way to find it, in my opinion. And this comes with the understanding that B is 2 pi f, okay? That's very common in engineering classes to teach that, in physics classes, okay? So you should get familiar with that if you're going to be one of those STEM majors. Okay, now D, did it get shifted up or down? No, the midline's at 0. This is the midline, D. So D is 0, okay? Now the hardest one, in my opinion, is always C, okay? How do we get C? Well, this is sine. So at t equals 0, where does sine begin? It starts like right here, actually. Okay, or at k. Doesn't matter, but let's go from here, okay? So, however, our t equals 0, per the problem, is right here. So what happened to the sine curve? It got shifted to the left by how much? A quarter of a period. Okay, that's what we think in terms of period. It's easy to calculate how much to shift it now. Okay, it got shifted by a quarter cycle or a quarter of a period. So to the left, right? So it should be a plus here, so that's good. What's the period? 1 over 200. What's a quarter of that, or 1/4 of that? That's 1 over 800. C is 1 over 800. This is how we think about these modeling problems in terms of cycles and all that, and frequency and all that stuff. Okay, otherwise it's really hard to come up with these values. Okay, and if you think of it just purely in terms of horizontal shift, vertical shift, horizontal stretch, vertical stretch, it's really hard it's not impossible, it's harder than knowing these characteristics, amplitude, frequency, period, all that stuff. Okay, part C, this is really easy. Okay, so T1 is the T coordinate of G, T2 is the T coordinate of J, okay? So is it decreasing or increasing? Clearly it's decreasing, so rule out A and C. Is it negative or positive? Clearly it's negative by our model, so D, negative and decreasing, okay? And lastly, on the interval T1 to T2, describe the concavity and determine whether the rate of change of H is increasing and decreasing. What's the concavity here? It's concave up. You can think of it as, if it's a bowl, is it opening upward or is it upside down? It's up, right side up, so concave up, okay? Like over here, the bowl is upside down, right? So it's concave down, okay? You can think of that to quickly get the concavity in a lot of the cases, okay? So what does it mean when it's concave up? What happens to the rate of change? It's increasing, okay? So that's what concave up is. And if you know in calculus terms for some reason, concave up means the second derivative is positive. So the rate of change of H is increasing, okay? H itself is decreasing, but the rate of change of H is increasing, okay? Don't get confused by that. All right, let me show the answers one more time. That's it. Hopefully this is helpful. Seems like a very standard problem in the AP Precalculus exam, so if you're studying and you're watching this in the future, know how to model these well. There's now 3 or 4 examples of these released by the College Board, so study them well.